Okay, so the first part is asking you to determine if it's arithmetic or geometric. Okay, so the first one going from -6 to -13 to -19. Okay, we're adding a -6. Okay, which makes it arithmetic. Second one, they put it in the form of the equation. So you just have to be able to recognize the equation, okay, as arithmetic. And remember which part is your generator, which is that part right there, right? Also kind of the slope. On C, we go from 96 to 24 and then 24 to 6. So it's kind of tough to tell what's happening from 96 to 24. Okay, however, going from 24 to 6, okay, it's either dividing by 4 or subtracting 18. Obviously, we're not subtracting 18 to go from 96 to 24. Okay. So we should be able to recognize it as geometric. And remember, we don't want to say dividing by 4. We want to say we're multiplying by 1/4. Okay, number 2, Leonard wants to show Penny how much he cares for her. So sweet. So he gets her a bunch of roses. First day, he gives her 2. Second day, he gives 5. Third day, he gives 8. So day 1, he gives 2. Day 2, he gives 5. Day 3, he gives 8. So hopefully you can kind of recognize that we are adding 3 each time here. Okay, this won't be on the test tomorrow, however, or Friday, whenever. Discrete continuous would mean continuous. If you were thinking about it in terms of a graph, would you be connecting the dots? Okay, you wouldn't be connecting the dots because you can't really give like 2.7 roses to somebody on day 1.4. Right, that doesn't make any sense. So we would say it's discrete. If we were going to graph it, we would only be plotting those points. So to write the equation, we would say T of n equals, given 3 roses a day, 3 more roses a day. Okay, then we have to think about what would be day 0, in this case, -1. So then to find out how many he gives her on day 46, you could write out 46 days, which would take a long time, or you can plug it into the equation. So we get 3 times 46 minus 1 should be 137. Okay. Rebound ratio. Okay, we did this at the beginning of the chapter. Feels like forever ago, even though it was probably like last week. Okay, rebound ratio, your rebound height divided by your starting height gives you your rebound ratio. 2814 divided by 30,000, rebound ratio of 0.938. Okay, so our rebound ratio 0.938. If we were going to write the equation, remember it's our starting height, which was 3,000, multiplied by a rebound ratio 0.938, raised to the nth power. So that way, when you need to find the third or the 15th ounce, you're just plugging in 3 or 15 for n. So the third bound should be at about 2,475.88 centimeters. Do the same thing for the 15th bounce. $1,148.59 centimeters. On number 4, Dino and Jessica were doing their homework. They got a sequence with only 2 numbers, so 7 and 21. Okay, so Dino thinks it's arithmetic. So he would go 7, 21. We're adding 14 each time, so he would continue to add 14. 63, 77, 91, okay, so on and so forth. Okay, and our equation would be T of n equals 14n, because that's how much we're adding each time. Work backwards, 7 minus 14 would give us -7. If Jessica's right, she thinks it's geometric to where we're multiplying by 3 each time. So 7, 21, 63, 189, 567, 1701, okay, so on and so forth. Okay, so we'd use our geometric equation, which is our 0th term, work backwards, multiplying by 3, so divide by 3. So our 0th term would be 7/3, multiplying by 3 each time, raised to the nth power. So then part C says 5/11's an output, so who's right? Well, even if we didn't want to do anything, we could just take a look. Obviously, 5/11 gets skipped over in the geometric sequence, okay, where it would need to fall somewhere in there. Okay, so we know it's not geometric. We can either assume it's arithmetic and say that, or we can plug it in as our output to our equation, and we're essentially just looking for a whole number. So we get 518 equals 14n, divide by 14, and n equals 37. So that means it is part, if 5/11 is an output, then we should be using the arithmetic. Okay, if you got an answer that was like n equals 14.2 or something like that, okay, that wouldn't make any sense. You don't have like a 14.2 term of the sequence. Okay, it would have to be a whole number. Okay, number 5, okay, mostly we only are looking at option 1 here, okay, but we'll do both of them. So you have $8,000 from your grandma, you're going to invest it for 20 years, okay, you have 2 options. So recall, whatever our starting amount is 8,000. When we're dealing with percentages, it's always 1 plus or minus your percentage. So in this case, it's 1 plus 0.0667, okay, raised to the nth power. So we end up with 8,000 times 1.0667 raised to the 20th. Plug it in on your calculator, obviously, 1.0667 raised to the 20th. Okay, and you'd have about $29,102.87. Okay. Option 2 is a little bit different. It's not going to be on the test, but we'll talk about it for a second here. Where you're compounding weekly just means that instead of doing it once a year, you're going to do it every week for the year. There's 52 weeks in a year. So how that works is you take your percentage, in this case, 0.065, okay, and you're going to split that up over the course of the year. And then since we're talking about 52 weeks, it would be 52. But you would also multiply your compounds by 52 as well. Okay, so you plug that into a calculator and you'd end up getting $29,330.55. Okay, pretty similar numbers. If you wanted to know which one you would use, obviously you would do that one for the extra $228. Okay, but again, we're only going to be testing you on option one type stuff. All right. Okay, second page. Given a sequence, write the equation, 22, 19, 16. Okay, we're subtracting 3 each time. So T of n equals -3n. What would come before, in this case, 25. Second one's geometric. We're dividing by 3, or as we should be saying, multiplying by 1/3. So we have 1/3 as our generator. Okay, work backwards. What would come before 300? Should be 900. So our equation would be T of n equals 900 times 1/3 raised to the nth power. Okay, and number 12, Digger the dog saves the same number of bones each week. Okay, since he's saving the same amount, it should be arithmetic. Okay, a couple different ways we can try and solve this. Since we know after week 5 he has 20, if we just come down to the table where n is our number of weeks, T of n would be our number of bones. So week 5 he's got 20. Okay, week 8 he's got 29. A lot of different ways you can figure out that he's adding 3 bones each week. Okay, you could have came over to the graph and plotted 520, 829, drawn a line, find the y-intercept, kind of go that way. Okay, you could treat these as points and say 520 and 829 and find the slope. So you get 9/3, which is 3. So that would be our slope, or how many bones we're adding each week. And you notice if we just add it on to the table, it checks out 23, 26, 29. Work backwards. Okay, so to write my rule, I know I'm adding 3 each week. And I started with 5, or Digger started with 5. The graph, you would just say 0, 1, 2, 3, 4, 5. You would have 3 more each week. Okay, I'm not going to connect the dots because okay, he's not really going to have a half a bone. Okay. So then if we wanted to find out how many bones or how many weeks until he has 101 bones, we could just keep on with our table until we get to 101, which would kind of take a long time. Okay, but we want T of n to equal 101, and we want to solve for the number of weeks. Okay, if it said how many bones is it going to have in 101 weeks, we'd plug in 101 for n, but since our number of bones is T of n, that's why we're plugging in 101 for T of n. So we subtract 5, we get 96 equals 3n, divide by 3, so n equals 32. So in 32 weeks, he would have 101 bones.